Hi everyone, I'm Adam. In this problem, we're going to be using a graphing utility to sketch the graph given by our polar equation r equals 1 plus 2 times the sine of theta. And then we're going to be finding the area of the inner loop of that curve. So first let's take our graphing utility and come up with a sketch of the graph. So to start with, let's go to our mode setting and make sure we're in polar coordinates. Then go into our function input. So for y equals, we should be looking at something like r or r1 equals. So we'll type in our equation, 1 plus 2 sine of theta, or whatever angle you have. Okay, and next let's set the window. So for the window, for our theta min, we'll go from 0 and our theta max to 2 pi. So theta going from 0 to 2 pi, and we'll take the theta step by, say, 0.1. Something small enough to get a good smooth picture. Now for our x min, we'll go from -3 to our x max, +3, and x scale will count by 1. And y min will go from -1 to y max at 3.5, and y scale will count by 1. And we should be good to go if we press the graph button. So we should be seeing sketched out something similar to the graph that we have sketched here. Okay? So that's the graph of our polar equation. And now what we want to do is we want to find the area of the inner loop. So the inner loop is this little loop right here. So specifically, we're wanting to find the area of this part right here. And how are we going to do that? Well, we know that the area under a curve in polar coordinates is equal to 1/2 times the integral from some limits alpha to beta of the function f of theta squared d theta, where f of theta is just what our r is. So r is f of theta. Okay, so we have the f of theta to plug in, and we can simplify there. But before we go on, we should find what our limits alpha and beta are. So looking at our curve, as we watched it being sketched out, our curve goes from the origin, looping around back to the origin. So our alpha and beta are going to be equivalent to what angles make r equal to 0, since it's going through the origin. So that's what we're going to take a look at. So we want to know where r is equal to 0, or our equation r is 1 plus 2 sine of theta. So what angles make that equal to 0? So we're going to solve this for theta. Well, subtracting 1 and dividing by 2, we have sine of theta is equal to, say, -1/2. And what values or what angles give sine equal to -1/2? Let's see, we have theta equal to, say, would be 7 pi over 6 and 11 pi over 6. So that's our alpha and our beta, respectively. So we can plug these in, coming back over here. So our integral, we're going to have 1/2 times the integral from 7 pi over 6 to 11 pi over 6 of our f of theta squared, or 1 plus 2 sine theta, quantity squared, d theta. So go ahead and squaring this out. Let's see, we're going to have 1/2 times our integral from 7 pi over 6 to 11 pi over 6. So foiling this, we'll have 1 plus, say, 4 sine theta plus 4 sine squared theta and d theta. And now we want to try and work on taking the antiderivative of what we have. So 1 and 4 sine theta is okay, but sine squared, we're going to want to convert this. So for sine squared of theta, we know that can be written as, or that is equal to, say 1 minus cosine of 2 theta over 2. So in place of our sine squared, we can write that. Now doing a little bit of simplification, we're multiplying this by 4, but this 2 can come to the outside and cancel with our 2 on the bottom, so giving us 2 times this quantity, 1 minus cosine 2 theta. So let's clean that up a little bit. So we again have 1/2 times the integral from 7 pi over 6 to 11 pi over 6 of 1 plus 4 sine theta plus, again, 2 times this quantity, 1 minus cosine 2 theta, so it'll be plus 2 minus 2 cosine of 2 theta and d theta. Okay, and put things together just a little bit more. So we have 1/2 times the integral, 7 pi over 6 to 11 pi over 6. So our constant 2 plus 1 will give us 3 plus 4 sine theta minus 2 cosine of 2 theta and d theta. Okay, we're about as simplified as we can go, to the point where we can now start taking the antiderivative of these parts. So we can take the antiderivative of 3 sine, but then cosine of 2 theta. If we were to do it the long way, we'd have to do a u substitution. But we can kind of shorten our work through doing u substitution. We can know that generally, if we take the antiderivative of cosine times some a times theta, this will be equal to, say, 1 over a sine of a times theta, and technically plus some c if there's no limits of integration. So we can use that. Now, going back through, so now taking our antiderivative, we're going to have 1/2 times the quantity antiderivative of 3 with respect to theta is 3 theta, and then minus 4 cosine theta, and then minus our 2, right, which is here, but then the 1 over a, our a is going to be the 2 in here, so that'll be 2 over 2 times sine of 2 theta, and then evaluate all this from 7 pi over 6, say, to 11 pi over 6. And of course, our 2's here are going to cancel. Okay, so now what we have to do is taking everything here, plugging in our upper limit, 11 pi over 6, 11 pi over 6, and then subtracting the entire expression with 7 pi over 6 plugged in, our lower limit. So let's start that here. So we're going to have, say, 1/2 times 3 times theta, so our theta is 11 pi over 6, times 3 would be, say, 11 pi over 2, minus 4 times cosine of 11 pi over 6. Well, that's root 3 over 2. And then minus sine of 2 times 11 pi over 6, or sine of 11 pi over 3, would be minus, say, negative root 3 over 2. And then we're subtracting this value 1/2 times the entire expression with 7 pi over 6 plugged in. So 7 pi over 6, so 3 times that would be 7 pi over 2. Then minus 4 times cosine at 7 pi over 6 would give us negative root 3 over 2. And then minus sine of 2 times 7 pi over 6, or 7 pi over 3, would be minus positive root 3 over 2. Okay, now we're just going to simplify this as far as we can. Let's come up over here and give ourselves some space. Okay, so first let's simplify things on the inside. So this 2 is going to cancel here, giving us a negative 2 times root 3. These two negatives will give us a plus. Coming over here, this 4 and this 2 will cancel, giving us, say, a positive 2 times root 3. Okay, now we'll clean this up just a little bit more. So noticing what we can do is factor this 1/2 all the way to the outside. So we'll take this as 1/2 times the quantity. And now taking our negative and multiplying through, we're going to do some subtraction. So we'll take 11 pi over 2 minus 7 pi over 2, and then our minus 2 root 3 with our negative here, minus 2 root 3, and then our positive root 3 over 2, and then minus minus plus root 3 over 2. So giving us 1/2. Okay, 11 pi over 2 minus 7 pi over 2 is 4 pi over 2. And minus 2 root 3 minus 2 root 3 gives us minus 4 root 3. And then root 3 plus root 3 gives us plus 2 root 3. I'm sorry. Root 3 over 2 plus root 3 over 2 gives us 2 root 3 over 2. And cleaning up just one more step, our 2's will cancel. 2 will cancel with this 4, giving us a 2. And so in the end, so this will be equal to 1/2 times 2 pi, and then minus 4 times root 3 plus root 3 will give us minus 3 root 3. So there we have the area of the inner loop of our curve. Thank you very much.